If you want the same kind of agent workflow on your own machine, check out conductor.com. Conductor works with the coding agents already in your current setup. It runs fully local, and I'll also show the open source repo and native coding agent screenshots later in this video. Supermemory just posted one of the boldest claims in agent infrastructure right now. They say they broke the frontier in agent memory and hit roughly 99% on LongMemEval-s with a new experimental technique called ASMR, Agentic Search, and Memory Retrieval. That sounds huge, and it is. But the number alone is not actually the most interesting part. The more important story is what they changed in the retrieval architecture to get there. Because memory systems usually do not fail because the model cannot reason at all. They fail because the right context never makes it into the window cleanly enough in the first place. So this is not really a story about one benchmark score. It is a story about whether agent memory is moving from vector lookup into agentic retrieval orchestration. Memory is one of the biggest unsolved problems in agents. Every serious agent product eventually runs into the same wall. You need the system to remember facts across sessions, handle contradictions, notice updates, resolve time correctly, and avoid dragging stale junk into the context every time a user asks something simple. That is harder than it sounds. Standard vector retrieval is fine when you want broad semantic similarity. It is much worse when the question depends on what changed, what came later, what contradicted something earlier, or which fact is still current. And that is exactly why benchmarks like LongMemEval matter. They are trying to test long-horizon, messy, multi-session memory under realistic noise. Not just whether a system can search one neat chunk store. So if a company is really moving from the mid-80s into the high 90s on that kind of benchmark, that deserves attention. This post does not have a normal demo video. It is really a research-style X article with proof graphics. So let's walk through the actual evidence it gives us. The first proof asset is the launch card. It says Supermemory is #1 in agent memory and introduces ASMR. That is basically the headline slide. The second proof asset is more important. It is the architecture diagram. You can see data ingestion, a knowledge store, active search, and what they call a decision forest and consensus layer. There are observer agents for extraction and separate search agents for retrieval and reasoning. That immediately tells you the core bet. They are not treating memory as one embedding lookup. They are treating it as an orchestrated multi-agent retrieval problem. Then the strongest proof asset is the benchmark table. It compares multiple systems across categories like knowledge updates, single-session assistant, single-session user, temporal reasoning, multi-session reasoning, and preferences. The OCR visible totals show Supermemory at 98.6% for the 8-variant ensemble, 97.2% for the 12-variant forest, and lower numbers for competing systems like Mostra Internal plus GPT, for O, Emergence MEM, and ZEP. Then the last proof graphic turns the same benchmark results into a chart for easier sharing. So the post is pretty clear about what it is proving. This is not a UI demo. It is an architecture and benchmark announcement. Now let's separate the exciting part from the careful part. The post itself explicitly says this ASMR setup is not yet in the main production Supermemory engine. That is important. So the safest reading is not that their production memory product has already fully become this system. The safest reading is that they built an experimental agentic retrieval flow to test how far they could push memory performance when they were not constrained by their normal production setup. The official Supermemory site and GitHub already support the broader memory story. They position Supermemory as a memory and context engine for AI, not just a vector database, and they already claim benchmark leadership across LongMemEval, LocoMO, and ConvoMEM. So the new post fits their existing direction. It just pushes the retrieval architecture harder. This is where the post gets genuinely interesting. If these results hold up, the big lesson is not simply that Supermemory has a better memory score. The deeper lesson is that long-term agent memory may be more of a retrieval architecture problem than a raw model intelligence problem. In other words, the breakthrough may come from how we search, filter, compare, and reconcile memory, not just from using a smarter base model. That matters a lot. Because if memory becomes more reliable, agents become more useful everywhere. Personalization gets better. Long-running workflows get better. Context handoff gets better. And platforms that solve memory well start building a serious moat because users do not want to reteach their systems the same things forever. Zooming out, this fits the bigger trend we keep seeing across the agent space. The products that win are not just the ones with strong chat. They are the ones with stronger infrastructure, memory, orchestration, tools, execution, and context that survives over time. That is also why I keep pointing to ConductorOSS.com and the Conductor OSS repo at github.com/tyrannyk06/conductor-OSS. I'll show the repo, the native coding agent launch screens, and the current local setup on screen here. Conductor works with the coding agents already in your setup, and it runs fully local. Supermemory is pushing the memory layer. Conductor is pushing the orchestration layer. Different layer, same broader truth. The next wave of AI products will be won by systems that can actually hold state, coordinate work, and stay useful over time. If you want more breakdowns like this, subscribe. And if you want an agent setup that works with all your current coding agents and runs fully local, go to ConductorOSS.com and check the open-source Conductor repo. The future belongs to AI systems that do not just answer, they remember, coordinate, and keep working.